test I take, I get an A. Yeah, screaming that's none. When I pulled out the lock, that's done. Doing my thing, homework all day, every day. Triggers it, triggers it, triggers it, triggers it. Seeing Mr. Ng's face during period 3, triggers it, triggers it.
Hey guys, let's go over 1.75, solve a quadratic inequality algebraically. I'm going to go to dark mode. Question number 1, do this with me and then pick either 19 or 20. Gardening. Marcus is planting a garden. He has enough soil to cover 104 square feet and wants the dimensions of the garden to be at least 5 feet by 10 feet. If he wants to increase the length and width by the same number of feet, by what value can he increase the dimensions of the garden without needing to buy more soil? Create a quadratic inequality and solve it algebraically. So let's go ahead and draw a picture. So here's my picture. We know that this is 5 by 10. And we want to increase it by the same amount, same number by feet. So I'm going to call that one x. Okay, so there is the blue area is going to be what we're trying to increase it by. Okay, so if area is length times width, and let's just call this one width, so this would be 5 plus x, or x plus 5. In this whole new area, we'll call length, that will be 10 plus x. And we want this area to be 103 feet. And we want the right side of the equation to be smaller than. Now again, you might say, Mr. Ng, you just wrote greater than or equal to, but remember, you're going to have to read this right to left. The right side is smaller than or equal to 103 feet. Okay, I'm going to box this one and star it because this is our inequality. And I'm going to do step number 2 here is we're going to try to solve this. And in order to solve, I'm going to have to distribute those two binomials. And to do that, I'm going to use the box method, which is essentially the same thing as FOIL, just multiplying binomials here. 10 times 5 is 50. 10 times x is 10x. 5 times x is 5x. And x times x is x squared. So the right side of the inequality is going to be x squared. We add these together now, so that'll be 15x, and this one will be 50. And then I'm going to go ahead and subtract 103, and we're going to get 0 because, let's write that, solve quadratics by setting what? Setting equal to 0. Okay. And I believe this is going to be negative 53. I realized that it's 104. And this would give me negative 54. Okay, how do I solve the inequality? Well, the easiest method, but won't always work, is to factor. So let's go ahead and try factoring this. So this is A, B, and C. So A times C is going to be negative 54. My B value is 15. And the factors of 54 are 54 and 1, 27 and 2, 3 and 18, and 9, and 6. And I see 18 and 3. We need to multiply those to be a negative, so one of these has to be a negative. I'm going to choose negative 3 because if I do 18 minus 3 equals 15. Now, if you haven't noticed, we have a quote-unquote trick. Well, not trick, observation, or shortcut. We had said that if you're factoring something that has an a value less than 1, then all you have to do is the x in factoring. You only have to use the box, or x and the box, when a is greater than 1. If you're not sure, go ahead and just use the box and you'll get x plus 18, x minus 3. Okay, to solve, I'm just going to set each of these equal to 0. It's called the zero product rule. One of these binomials has to equal 0. And you'll get x equals negative 18 and x equals 3. Okay, let's go ahead and plot the solutions on a number line. And I know the parabola is facing up because we have a is positive. I know the c value is negative 54. And in pink, we just had 3, and let's say this is 18. So my parabola is probably going to look something like this. Okay. Okay, what we need to do now is test the intervals. Test a value from each of the intervals. And I will do that, hopefully color-coded. I need to pick a number far out here, and I'm going to pick 20. You could have picked at 19, you could have picked 100. I chose 20 because when I think it's just easier to multiply. I'm going to pick a number in between to test, and I'm going to pick 0. And on the far right side, I'm going to pick, over here in the green region, I'll call it, I'm going to pick 4. So let's go ahead and test this inequality. You can use any of the inequalities. What I mean by that, you can use a star boxed, or you can use this one down here, the second starred one. It doesn't matter which one you choose to use. I'll use this one, because I can do some magic. All right, we're going to do this 3 times. Okay, let's go ahead and test 20. Okay, you have 30 times 25 is greater than or equal to 104. Obviously, it's going to be a very big number, and that big number cannot be smaller than 104. Let me go ahead and multiply that. That's 750. Is 104 bigger than 750? This would be false. So we would say no shade. So in this region, I'm just going to write the word no. Okay, let's do the orange region of 0. So this would give me 10 times 5, which would give me 50. And is 104 greater than 50? That is true. So yes, shade. So our shaded region would be here. And the last one is the green region. All right, so I have the green region is 4. So this would give me 14 times 9, which would give me 126. And is that true or false? That would be false, so no shade. Okay, so I'm just going to write the word no. So let's get another color in here that I have not used. Let's try purple. And let's make it a little bit thicker. Chose the wrong one. So basically my solutions here are here in purple that I'm drawing. So as an interval notation, I can have an answer between -18 and 3. And I'm putting brackets because it includes that solution. That should have been -18. But because it's a closed circle, it's a bracket. Now this is kind of weird. I'm going to label this my fake answer. It's a fake answer because it is an answer to the algebraic, but it is not a real answer to the real world. Okay, let's think about this. If I put in -18 for x, -18 plus 10 would give me -8. Can you have a length that is negative? In the real world, that is not real. That doesn't make sense. You would a negative x value is basically decreasing the length of your flower bed or whatever garden is. Does that make sense? So that means the real thing is I want a number that is not only at 0, I want positive numbers. So the parentheses means do not include 0. So don't pick 0 because it's not going to do anything. I guess it's equals to, but it's not really changing it. And I'm going all the way up to 3. If I go past 3, it would require more dirt than the 103. Okay, the next one is called an inequality, or a fancier way of saying that is called set builder notation. If I want a number that is, smaller than 3, smaller than or equal to 3, but I want the same number, pay attention, to be greater than or equal to -18. Okay, you might ask, reading from left to right, that says -18 is less than or equal to x. But remember now, this is a compound inequality, so you can write it just like this. X is bigger than or equal to -18. Notice how that inequality is pointing to the -18, so when I put these two inequalities together, the inequality has to point to whatever you have there. In this case, they're pointing, it's pointing to the -18, and then x is less than or equal to 3. It's pointing to the 3. So in your compound inequalities, you'll notice the inequalities are always going one direction. And then this one, I just want one that is greater than, well, a real world, which just means I want smaller than 3 but bigger than 0. And to make this set builder notation super fancy, I think inequality to interval notations is simple enough. In the set such as x, x can only be between bigger than -18 and bigger than 3. And so I'm trying to point out here in what I'm drawing in white is this is what makes a set builder notation. Okay, so we can increase the bed size by making an x value that's greater than 0 and less than or equal to 3. Okay, so in 1.75, instead of number 19, I think it was the fencing problem, I'm replacing it with this pool problem. A rectangular pool is currently 20 feet long and 15 feet wide. So draw a picture. This is 15 and 20. Hadley wants to increase both the length and the width with the same amount. So the same amount is going to be x. So here also x, to create a larger pole. However, she can only afford enough tiles to cover an additional 20 square feet. So let me color it in. This blue portion is the additional 20 square feet of pole surface. What is the maximum increase in length and width that she can afford? Okay, one thing that we need to note is the original pole, 15 times 20 is 300. So this is 300 square feet, and she can afford 200 more square feet. 200 plus 300 gives me a total of 500. Now the units aren't important. Okay, so the first thing I'm going to do is we drew a picture. Let's call that step 0. And then step number 1, we need to create a quadratic inequality. So my quadratic inequality, my first one, is going to be, the length and the width actually don't matter which one you pick. That's going to be my first equation, x plus 15. And then my second one is this side. So that'll be 20 plus x. 20 plus x. And then if you think about it, if the new pool is going to be 500 square feet, that means it cannot be bigger than 500. So I want less than or equals to 500. So that is step 1, determine the quadratic inequality. Okay. Step 2 is to solve for the inequality. So let's solve it. That means getting for x. So what I'm going to do here, let's use yellow. I'm going to multiply these two using a box. Remember, 20 plus x is the same thing as x plus 20. I'm going to go ahead and multiply these. So I have 20x, 300, x squared, and 15x. So I have x squared. This is 35x plus 300 is less than or equal to 500. So all I did there was double distribution, FOIL, using or multiplying. Okay, now I want it to set it equal to 0. So I'm going to go ahead and subtract 500 from both sides. And then I'm left with x squared plus 35x minus 200 is less than or equal to 0. The easiest way is to see if we can factor this. So let's factor it. A times C is negative 200. Your B value is 35. So my calculator trick is to put it in your table of values. So I have 200 divided by x. Can't type 200. And then if I go to my table, these are the numbers that multiply to be 200. And so basically what I want to figure out is these two numbers now add or subtract to be 35. So for example, 50 times 4 is 200, but 50 minus 4 is 46 and not 35. I'm looking for whole numbers. So it looks like this number, 40 and 5. now I'm going to factor. I'm going to make this one negative. So 40 times negative 5 is negative 200, and then 40 minus 5, or 40 plus negative 5 is 35. So x plus 40, and x minus 5. And then if I solve this, set it equal to 0, get x equals negative 40, and x equals 5. Okay, these are the two that I want from the graph as a visual. So that was step number 2, solve the inequality. Step number 3, steps 3, plot the solutions on a number line. So let's go ahead and do that. Here is 5, and here is 40. And so now we want to test the inequality. We want to know where they're true and false. You can type this into your calculator to speed up the process. Remember, you're going to pick from last week's lesson. We picked 3 regions, which was purple, yellow, and green. So you're picking numbers inside these regions. Remember, do not pick those exact numbers. So say you pick 41. I'm going to pick 0. And in orange, I'm probably going to pick 6. And then when I put in the number, I am testing it with, is it less than or equal to 0? So I'm letting the calculator do the work, and obviously you can put it in there. Okay, 0 is negative 200. So is negative 200 smaller than 0? The answer is true. And then if I chose 6, that is 46. Is 46 smaller than 0? That would be false. Okay. So in class, we talked about how it's negative 40. Oh, I chose the wrong number. Negative 40. Okay, that would be 46. And 46 is less than 0. That's false. Okay, so our interval notation, we would just said our answer is negative 40. It would be a bracket because we have equals to 5. But in real life, so we did step number 4 here, we're testing the values, is you cannot have negative numbers for a pool. So you'd probably want to do something like 0 to 5. Now, of course, if you chose 0, the pool's not going to increase. But if you chose, say, 1, you can put in 20 plus 1 is 21, and 1 plus 15 is 16, and so when you multiply those numbers, it's going to be less than 500, which you can afford. So your answer in interval notation is 0 to 5.
Hey guys, let's go over question number 20. A homeowner wants to increase the size of a rectangular deck that now measures 8 by 10. But the building code states that you cannot have a deck larger than 120. If the length and width are to be increased by the same amount, I'm going to call that one x, find to the nearest tenth the maximum number of feet that the length of the deck may be increased in size legally. So if we increase it by the same amount, which is x, That means this whole area so if this is 80, and we're saying altogether the total cannot be more than, has to be less than 120. So let's go into use step 0 is our picture. We got that. And then number 1, we'll just have x plus 8. And then the other one, 10 plus x, or x plus 10, is less than or equal to 120. Okay, so let's go ahead and expand that. X plus 8, x plus 10, x squared, 10x, 8x, and 80. So that would give us x squared. Add these two, you get 18x, and then you have plus 80. All right, I'm going to subtract 120. X squared plus 18x minus 40 is less than or equal to 0. So now what we're trying to do here is we are doing solve. So this is right, and this is now solve. So I'm going to see if I can factor that. A times C is negative 40. Our B value is 18. Remember, you can always list out your factors. So it looks like 20 and 2. See if that works. So I have x plus 20, x minus 2. And then we're going to solve that. Set it equal to 0. So when I graph this, we'll have 2 and negative 20. And then this year, we learned to test this region. So say negative 21. This region will test 0. And let's test over here. Let's test 3. So when you put in those numbers, so if you put in negative 21 into that original problem, for purple, negative, negative, you get positive, so that is false. So not this area. Okay, let's do the middle area. 0. So you're going to get 20 times negative 2, negative 40, and that is true. So it's going to be that in between. And let's go to the last one, 3. So 23 is smaller than 0. That is false. Okay, so that means our answer has to be between negative 20 and 2. But remember, x, or the numbers I have, don't match that. We can have a negative increase, so you would start here at 0. So our answer would be from 0 to 2.
We doing math today, ain't got time for no games. We doing math today, all work and no play. We doing math today, listen up and behave. We doing math today, we doing math today.